So in this last part of the list transformer video, what we're going to do now is we're just going to wrap up everything that we've been learning so far, and we're going to finally make some we're going to basically create an instance of the monad transformer type class. So let's just put a title of today's video. We're still continuing our learning on list transformers, and let's just get a type definition here that we had earlier in the video. And what we had was the following type definition, where we had list t ma equals to list t, and the first it had only one field here. It was just a wrapper. We just had a wrapper list t ma. This was acting as a wrapper on the following value. Okay, and what we're going to do now is we're going to create an instance of the monad trans class in Haskell. So before you do that, let's just quickly get the class definition here. So the monad trans class is defined as follows. The actual class definition, the actual type class definition is class monad trans, and this is type variable on key, where the type signature for the lift method is as follows. The lift method has a constraint. The constraint is that I must have the m that I'm going to use right now must be a monad, and the signature is as follows. The first argument is a monadic value of ma, and in return it's going to get lifted. I'm going to lift the value, the monadic value ma, by having it wrapped in tma. Okay, so what does this mean here? Okay, let's just try to use some of the material that we have learned on kind to infer this out. So what I know is that from this type signature, MA is something that must be a concrete type. This is going to be a concrete type, so the kind is going to be a star, and this entire thing over here is going to be another concrete type, so the kind on TMA is also going to be a star. Okay, so far so good. I can also assume at this point that A is something that has a concrete type star, and I only know constraint M here, that M is a monad. So let's just do this. Let's just rewrite this. The kind for A is just a concrete type. The kind for M is something that goes from a star to a star. So M is acting as a type constructor. It's a type constructor that takes in some concrete type and gives you back another concrete type. And now it's easy to see that T is something that takes in a star, which is M, followed by A, which is a star, giving you back the concrete type star. Okay, again, just this entire piece over here represents my M. This entire piece over here represents my A, and this is the concrete type that gets taken out as output after having fed M and A to my type constructor T. Okay, so now that I know that anything that needs to be an instance of the monad trans must have a type signature, this must have a type signature that goes from star to a star. That's my first parameter, and then a star to a star. That's a kind signature for T. Can I figure out what the kind signature for my MA and list T is? Now, from the last video, I'm just going to rewrite this quickly here, is that I knew that the kind signature for A in this case being from this A over here, has a signature of a kind signature of a star. M has a kind signature that goes from a star to a star. And then finally, I know that list T has a kind signature that goes in from a star to a star. This is my M. And then finally, it takes in A as a second parameter. A has a kind signature of a star. And then finally, I get back as an output a concrete type, a star. Okay, so if I want to make something an instance of the monad trans, I must be passing in this place of t anything as long as that anything matches this kind signature. Okay, and I already know that list t is one such example. List t has the following kind signature, which completely matches the kind signature for this t here, which means now I'm in a position at this point to make my list t and instance of the monad trans class. Okay, so I can do this easily. Let's just implement the lift method. So if I were to implement the lift method, so of course I'm just missing the actual Haskell boilerplate code where I'm just going to say instance of my monad trans where t is going to be lift t. Okay, so wherever I see these t's here, you can think of these t's now being replaced by list by being replaced by list t. So let me do this. Let me first write the type signature again, the standard type signature for the lift method in the monad trans class, where I have this as monad m, and that's the type constraint on m, where m must be a monad, and the first argument is ma, and I get back out as TMA. I'm just going to replace every single T with list T, because list T, remember, is going to be an instance of the monad trans class. So this is going to be, I'm just going to rewrite this. I'm just going to rewrite this again by lift now being monad M. This is MA, and T now is going to be list T. This is going to be list T and A. Okay, so how do I implement the lift method if I were to make list T an instance of the monad trans class? So I could say lift, pass in some value x here, okay, and the implementation is going to be as follows. Now I know from this the type of x is going to be this monadic is x is basically a monadic value which has a type of ma. Okay, and what I really want to do is I want to create a value of type list tma. Okay, so how do I create a value of list tma? Well, all I need to do is I need to invoke the value constructor. If I would invoke the value constructor and pass in appropriately the value of the first field as m of list of a, in essence, that would create for me a value which would have a type. It would have a type of list tma. So let's invoke a value constructor which is list t. Okay, and I'm just going to pass in the first value of my first field, which needs to be of type m of list of a. Okay, now what I really know is that if I look at this x here, x is a monadic value. X is a monadic value. If I can somehow tear apart, get rid of this context, get rid of this monad here, and just get the a out, just the a out from this monadic expression, then I can simply create a minimal array of size 1 out of that, and then just wrap it again in this monad m there. So first let's think about this. How am I going to tear it apart? So I can, because this x is a monadic value, I can use my do block here, and all I'm going to say is I'm going to take my x, and I'm going to separate out my monad out from it. So let's just call this just, I don't know, if you just want to be clear, let's just, instead of saying x here, let's just say xm. Okay, just so that it becomes a little bit clear that we are dealing with right now with a monadic value. So when I take this monadic value xm and I tear it apart, what I get back over here is just the x. I get just the purity, the x out of that monadic value. This x, so again, just to be consistent with the types here, xm has the type, it has a type of ma. X over here has a type of just a. Okay, now I've got some value x. This x contains some value that has a type of a, and now I can just take that x, which is over here, wrap it around my list, okay, to get this piece out, okay, this entire piece out there, Okay, let me just use a darker color here. So this is the piece that I've just got done. Let's put a checkbox there. And now all I need is this. I need this M there. So I can take this entire piece there and again wrap it up in some minimal context by invoking the return statement. Now remember this return over here again. As I said in my previous videos, this return that I'm invoking here is the implementation. To whatever this monad M is. Okay, this M could again be a list, maybe a state monad, it could be a reader or a writer monad, doesn't matter, whatever is the implementation of the return, and that M in that monad M gets invoked here. So this entire piece here has a type. It has a type of M of A. Okay, so I got my type correctly lined up. That's exactly what I wanted. I wanted type of M of list of A. I wanted type of M of list of A's. And now at this point, if I close my parentheses over here, I have an implementation to my lift method. Okay,